The SR-71 Blackbird shouldn't have existed. In 1959, when Lockheed's Skunk work started sketching an aircraft that could fly at 85,000 feet and Mach 3.2, the entire concept violated what most aeronautical engineers considered possible. Titanium airframes hadn't been done at that scale. Sustained supersonic cruise flight was theoretical. And the idea of a reconnaissance jet that would simply outrun enemy missiles instead of evading them? That sounded like bad science fiction. Kelly Johnson didn't care what sounded reasonable. The U-2 spy plane had just been shot down over the Soviet Union. Francis Gary Powers was in a Moscow prison cell, and Nikita Khrushchev was parading wreckage in front of international cameras. The message was clear. Subsonic reconnaissance aircraft were finished. If America wanted to keep photographing Soviet military installations, it needed something no missile could touch. So Johnson designed an aircraft out of titanium. Not aluminum, titanium, a metal so difficult to machine that Skunk Works engineers had to invent new drill bits just to work with it. The SR-71 skin would heat to 800 degrees Fahrenheit at cruise speed, expanding the entire airframe by nearly a foot. Fuel tanks were designed to leak on the ground because they'd only seal properly when superheated at altitude. This thing leaked jet fuel sitting on the runway, intentionally. The CIA funded the project under the designation A-12, later modified into the SR-71 for Air Force reconnaissance missions. First flight happened in 1964. The aircraft reached operational status in 1966, and immediately the Soviets realized they had a problem with no solution. Because the Blackbird didn't dodge missiles. It didn't need electronic countermeasures or chaff dispensers, or any defensive systems beyond a radar warning receiver. The standard operating procedure when surface-to-air missiles were detected was brutally simple. Push the throttles forward. Accelerate. The SR-71's defense was pure physics. By the time a SAM reached the Blackbird's altitude, the jet was already miles downrange. Soviet fire-controlled systems could track it, could launch at it, but couldn't catch it. They tried anyway. 4,000 times over the aircraft's operational life, enemy forces fired missiles at SR-71s. The success rate was zero, not nearly zero or statistically insignificant. Zero. Not one hit. Not one aircraft damaged by hostile fire in 3 decades of flying over the most heavily defended airspace on Earth. The first operational missions went to Vietnam in 1968. North Vietnamese air defenses were, at that point, the most concentrated anti-aircraft network ever assembled. Soviet SA-2 Guideline missiles, radar-guided and theoretically capable of intercepting high-altitude targets. MiG-21 interceptors scrambled whenever American reconnaissance flights were detected. And then this black dart-shaped thing appeared on radar screens traveling at speeds that seemed like equipment malfunction. I love that North Vietnamese radar operators initially thought their systems were broken. The returns showed an aircraft moving faster than anything in their identification manuals. Soviet advisors confirmed the readings were accurate. This was a real aircraft, but offered no useful guidance for shooting it down. There wasn't any guidance to offer. The Blackbird photographed targets, turned around, and left. If missiles launched, the pilot knew before the Vietnamese crews did. The SR-71 sensors detected radar lock and missile ignition automatically. Standard response. Watch the Mach meter climb past 3.0. No evasive maneuvers required, just speed. March 1968. The first SR-71 operational sortie over North Vietnam launched from Kadena Air Base in Okinawa. Pilot Major Jerome O'Malley and Reconnaissance Systems Officer Major Ed Payne climbed to 80,000 feet and pushed the Blackbird through Mach 3 as they crossed into hostile airspace. North Vietnamese air defense networks lit up immediately. The SA-2 Guideline missile, Soviet designation Vi-750VN, was designed specifically for high-altitude interception. Maximum engagement ceiling, 82,000 feet. Maximum speed, Mach 3.5. On paper, it could reach the SR-71. Soviet engineers had run the calculations. The missile had the altitude, it had the speed. What it didn't have was time, because intercept geometry isn't just about raw performance numbers. A surface-to-air missile doesn't chase an aircraft from behind. It leads the target, predicting where the aircraft will be when the missile arrives. Fire control computers calculate intercept points based on target speed, altitude, and direction. The problem was that SR-71s traveled so fast that by the time an SA-2 climbed to intercept altitude, the Blackbird had already passed the calculated intercept point and was accelerating away. The missile would arrive at empty sky. North Vietnamese crews fired anyway. Dozens of SAMs went up during that first mission. O'Malley and Payne watched missile contrails arc toward them from below, white streaks climbing through the atmosphere. The missiles would rise, reach apogee, and fall away behind as the Blackbird simply kept going. No dramatic evasive banking, no wild defensive maneuvers, just straight-line flight at sustained Mach 3.2. Hanoi's air defense commanders requested guidance from Soviet advisors. The Russians didn't have good answers. The SA-2 was their premier high-altitude missile system, and it was completely ineffective. Launching earlier didn't help. The missile still ran out of energy before reaching the target. Launching more missiles simultaneously just wasted more ordnance. I don't know what those conversations sounded like, but I imagine the frustration was incredible. MiG-21 interceptors tried next. The fishbed could theoretically reach 60,000 feet and Mach 2.05 in a clean configuration. But theoretically and operationally are different things. A MiG-21 climbing to maximum altitude burned fuel so rapidly that combat radius shrank to almost nothing. And even if a MiG managed to reach 60,000 feet, the SR-71 was still 20,000 feet higher and traveling a full Mach number faster. North Vietnamese pilots attempted intercepts anyway. Standard procedure was to climb as fast as possible, hoping to catch the Blackbird during its ingress run before it reached full speed. It never worked. The SR-71 cruised faster than the MiG-21's maximum speed. A pilot could push his interceptor to the edge of structural limits, redline every gauge, and still watch the American Reconnaissance jet pull away. Some MiG pilots reported visual sighting of the Blackbird, a dark shape at extreme altitude, condensation trails streaming behind. They'd fire air-to-air missiles anyway, knowing the engagement was hopeless. The missiles would climb, lose energy, and fall away. By mid-1968, North Vietnamese air defense forces had fired over 800 surface-to-air missiles at SR-71s. Hit rate, 0. Missions flown, every single one completed successfully. The Blackbird would cross North Vietnam, photograph military installations, SAM sites, troop concentrations, then turn southeast and exit over the Gulf of Tonkin. American intelligence analysts would have fresh reconnaissance imagery within hours. And there was nothing Hanoi could do about it. 4,000 missiles. That's the documented total fired at SR-71 aircraft during operational missions from 1968 through 1990. North Vietnam, Soviet Union border zones, Middle East, North Korea, Cuba. Everywhere the Blackbird flew, enemy air defenses tried to kill it. 0 hits. Not one successful intercept. Not a single SR-71 damaged by hostile fire. The most advanced surface-to-air missile systems in the Soviet arsenal, SA-2, SA-3, SA-5, SA-10, couldn't touch it. The failure rate wasn't embarrassing. It was absolute. Soviet air defense doctrine was built around layered missile coverage. Low-altitude systems for close-range threats, medium-altitude systems for conventional aircraft, high-altitude systems for strategic bombers and reconnaissance platforms. The SA-5 Gammon was specifically designed to counter high-altitude, high-speed targets, maximum range 180 miles, maximum altitude 100,000 feet, maximum speed Mach 3.5. Soviet engineers believed it could kill the Blackbird. They were wrong. The SA-5 had the performance envelope on paper, but missile performance and successful intercept are different problems. A SAM needs to predict where a target will be several minutes in the future, launch, climb to altitude, and arrive at precisely the right point in three-dimensional space. Against subsonic bombers, this works. Against Mach 3.2 reconnaissance jets, the math breaks down. Here's why. An SR-71 traveling at Mach 3.2 covers roughly 1 mile every 2 seconds. A SAM fire control system needs 10 seconds minimum to achieve radar lock, calculate intercept geometry, and launch. In those 15 seconds, the Blackbird travels 7 miles. By the time the missile leaves the launcher, the target is already far downrange from the predicted intercept point. And the SR-71 isn't maintaining constant speed, it's accelerating. Pilots had a standard response to missile warnings: advance the throttles. The Pratt & Whitney J58 engines would push the aircraft from Mach 3.2 to Mach 3.3, sometimes higher. That small speed increase completely invalidated the fire control solution. The missile would climb to the calculated intercept altitude and find nothing but empty sky. Soviet radar operators watched this happen hundreds of times. They'd track the Blackbird crossing their screens, achieve lock, launch missiles, and then watch the target pull away from the intercept zone. The missiles would reach maximum altitude, run out of energy, and fall back to Earth. Unguided. Harmless. Some tracking stations tried ripple firing, launching multiple missiles in sequence to bracket the target's projected flight path. Didn't matter. The SR-71 flew a predictable route, straight line, constant altitude, because it didn't need to evade. Speed was the only defense required. Soviet crews could see exactly where it was going and still couldn't hit it. The operational cost was staggering. SA-5 missiles weren't cheap. Each one represented significant manufacturing resources and technical expertise. Firing 4,000 missiles over 2 decades with zero return on investment wasn't just a tactical failure. It was a strategic humiliation. And the Americans knew it. SR-71 mission planners deliberately routed flights along Soviet borders, over contested airspace, through the heaviest air defense concentrations available. Not because they had to, the Blackbird's range allowed alternative routing, but because they could. Every failed intercept was a demonstration, a reminder that Soviet air defense networks, despite billions in development funding, couldn't stop one American reconnaissance jet. There's something almost cruel about it. The Soviets built an entire integrated air defense system: radar networks, command centers, missile batteries, interceptor squadrons, and the SR-71 made all of it irrelevant just by flying in a straight line. I think that might have been the worst part for them. Not that they couldn't shoot it down, that they couldn't even make it maneuver. Soviet radar operators had the worst job in air defense. Not because the equipment was bad. Soviet radar technology was actually quite sophisticated, but because they had to watch American aircraft violate their airspace and report their complete inability to do anything about it. The SR-71 showed up on radar screens as a clear, unmistakable return. No stealth characteristics, no radar-absorbing materials, just a large titanium aircraft flying at 80,000 feet, reflecting radar energy like a billboard. Soviet ground stations could track it perfectly. They knew exactly where it was, how fast it was moving, what altitude it maintained. The radar picture was textbook clear and completely useless. Standard Soviet intercept protocol required radar operators to immediately notify Air Defense Command when unidentified aircraft entered monitored airspace. Command would alert fighter bases and SAM batteries. Interceptors would scramble. Missile batteries would go to ready status. Fire control radars would acquire the target. And then everyone would watch the SR-71 cross the screen at 3,200 feet per second, while their intercept options evaporated. MiG-25 interceptors were supposed to solve this problem. The Foxbat was designed explicitly to counter high-altitude, high-speed American bombers and reconnaissance aircraft. Maximum speed, Mach 2.83. Service ceiling, 67,000 feet. The Soviets rushed it into production specifically because the SR-71 was making their air defense network look incompetent. It didn't help. The MiG-25 could reach Mach 2.83, but only in a straight line at optimal altitude with minimal fuel and no weapons payload. Combat radius at that speed was pathetic. The Foxbat burned fuel so fast that pilots had maybe 10 minutes at maximum speed before needing to turn back. And even if everything went perfectly, even if a MiG-25 somehow intercepted an SR-71, it was still 13,000 feet below the Blackbird's cruise altitude and half a Mach number slower. Soviet pilots tried anyway. They'd scramble on alert, climb as fast as the engines allowed, and watch the SR-71's contrail streak across the sky above them, completely unreachable. I've read debriefing reports where MiG-25 pilots described the frustration of seeing the target, knowing exactly where it was, and having zero ability to engage. Some pilots pushed their aircraft past design limits trying to get closer. The MiG-25's engines could briefly exceed Mach 2.83 in afterburner, but the thermal stress would damage the power plants. Pilots would return to base having destroyed their own engines without even getting weapons range on the target. Radar tracking stations had it worse. They couldn't even attempt intercept, just watch. Track the Blackbird as it entered Soviet-monitored airspace, maintain lock through the entire overflight, and then watch it exit. File a report documenting the intrusion. Do it again next week. The psychological impact shouldn't be underestimated. Soviet air defense personnel were trained to believe their systems were world-class, capable of defeating any American threat. And then this one aircraft, not a stealth bomber, not an experimental prototype, just a reconnaissance jet flying straight and level, proved that entire belief system wrong. Border region tracking stations became so familiar with SR-71 flight patterns that operators could predict when missions would occur. They'd see the Blackbird appear on radar along the usual route, track it for the usual duration, watch it disappear at the usual exit point. Routine, predictable, unstoppable. Soviet Air Defense Command tried everything. Different missile types, coordinated intercept attempts, pre-positioning fighters along known flight paths. Nothing worked. The SR-71 would appear, complete its reconnaissance run, and leave, every single time. And the worst part? The Americans weren't even hiding it. They published SR-71 performance specifications in aviation magazines. The speed, the altitude, the operational procedures. The Soviets knew exactly what they were facing and still couldn't counter it. The SR-71's operational record is almost boring in its perfection. 32 years of reconnaissance missions. Hostile airspace on 4 continents. 0 combat losses. Not low casualties. Not acceptable loss rates. 0. Cuba got the Blackbird treatment regularly after the 1962 missile crisis. American intelligence wanted continuous monitoring of Soviet military activities on the island, and the SR-71 provided it without Cuban air defenses being able to do anything about it. SA-2 missile batteries around Havana would light up their tracking radars, achieve lock, and fire. The Blackbird would photograph the missile launches, continue its reconnaissance run, and exit Cuban airspace with complete photo coverage of military installations. Cuban air defense crews were firing Soviet missiles at an American aircraft while that same aircraft photographed them firing the missiles. The absurdity must have been infuriating. Middle East operations were similarly one-sided. During the 1973 Yom Kippur War, SR-71s flew reconnaissance missions over the Suez Canal and Golan Heights, photographing Egyptian and Syrian troop positions. Soviets supplied SA-6 missile batteries, newer, supposedly more capable than the SA-2, engaged repeatedly. Same result. The Blackbird completed its mission and left. Israeli intelligence received reconnaissance imagery from SR-71 overflights showing Egyptian armor concentrations, SAM deployments, and artillery positions. The photographs were taken at 80,000 feet while Egyptian air defense forces were launching missiles at the aircraft taking those same photographs. North Korea tried for years. SA-2 and SA-3 batteries along the DMZ would engage SR-71s conducting surveillance runs over the peninsula. Dozens of missiles fired, 0 hits. The Blackbird would photograph North Korean military facilities, turn south, and return to Kadena Air Base with complete mission success. Soviet border reconnaissance was the most dangerous mission profile, deliberately flying along Soviet airspace boundaries, sometimes briefly crossing into Soviet territory, forcing air defense networks to react. The political stakes were higher. Soviet commanders had authorization to engage. MiG-25s would scramble. SA-5 batteries would go active. Radar tracking stations would coordinate intercept attempts. And the SR-71 would complete its mission anyway. There's one mission I particularly appreciate. 1981 reconnaissance flight along the Soviet Pacific coast. 2 MiG-25s attempted intercept, climbing to maximum altitude and maximum speed. Soviet ground control vectored them toward the Blackbird's projected flight path. The MiGs achieved visual contact, rare for intercept attempts, and the pilots actually saw the SR-71. They fired anyway, knowing it was futile. Air-to-air missiles tracked upward toward the Blackbird, lost energy, and fell away. The SR-71 pilot didn't even bother with evasive maneuvers, just maintained course and speed. The MiGs exhausted their fuel and had to disengage. Mission accomplished for the Americans. Complete failure for the Soviets. By the 1980s, Soviet air defense forces had largely given up on actual intercept attempts. They'd still light up radars when SR-71s were detected, still go through the motions of launching missiles, but everyone involved knew it was theater. The Blackbird would do whatever it came to do, and Soviet air defenses would file another failure report. 32 years, thousands of operational sorties, every major Cold War hotspot. The SR-71 flew reconnaissance missions in the most heavily defended airspace on Earth and never took a hit. Never got scratched. American intelligence agencies had real-time reconnaissance capability that Soviet air defenses couldn't touch. Not couldn't reliably counter. Couldn't touch at all. The strategic advantage was enormous. The United States could photograph Soviet military installations, track troop movements, monitor weapons development, and the Soviets had no effective response. They built missiles. They built interceptors. They built integrated air defense networks. And one American reconnaissance jet made all of it irrelevant. The SR-71 carried no countermeasures, no chaff dispensers, no flare launchers, no electronic jamming pods, no defensive systems whatsoever beyond a radar warning receiver that told the crew when they were being tracked. This wasn't an oversight. It was a statement. Most military aircraft are designed with layered defensive systems because they expect to be attacked and need ways to survive. The SR-71 was designed with the assumption that nothing would reach it. The engineers at Lockheed Skunk Works looked at Soviet missile performance, ran the intercept calculations, and concluded that speed alone was sufficient defense. They were right. The Pratt & Whitney J-58 engines were the entire defensive system. Each engine produced 3,500 pounds of thrust in full afterburner. At Mach 3.2, the engines weren't even operating as traditional turbojets anymore. They functioned as hybrid turbojet ramjets, with bypass tubes routing air around the compressor section directly into the afterburner. 60% of the SR-71's thrust at cruise speed came from the afterburner and bypass airflow, not the turbine itself. This is genuinely impressive engineering. The J-58 had to operate across an enormous performance envelope, from subsonic speeds at takeoff to sustained Mach 3+ cruise at altitude. The engine inlet spikes would move forward and backward to manage shockwave positioning, ensuring optimal airflow into the compressor. Get the spike position wrong and the engine would unstart. Catastrophic disruption of airflow that could tear the engine apart. SR-71 pilots learned to manage engine unstarts as routine emergencies. The aircraft would yaw violently when one engine flamed out. The pilot would reduce throttle on the operating engine, restart the dead engine, and continue the mission. No need to abort. Just deal with it and keep flying. Because the mission always continued. That was the whole point. Soviet missiles launch? Accelerate. Radar warning receiver shows multiple tracking radars? Maintain course. Engine unstarts at Mach 3.2 over hostile territory? Restart it and keep going. I love the absolute confidence this represents. American engineers built an aircraft with zero defensive systems because they trusted physics and engineering to keep it safe. Soviet engineers built layered air defense networks with redundant missile types and integrated tracking systems, and it didn't matter. 2 J-58 engines beat everything the Soviet Union could deploy. The fuel system was equally absurd. The SR-71 burned JP-7, a specialized fuel with an extremely high flash point. You could drop a lit match into JP-7 and it wouldn't ignite. The fuel required chemical ignition from trithylborane, TEB, injectors to start burning in the engines. The aircraft carried enough TEB for 16 engine starts, and that was it. Run out of TEB at altitude and you're gliding home, because JP-7 won't ignite without it. This actually happened on a few missions. Pilots would experience multiple engine unstarts, burn through TEB cartridges attempting restarts, and end up with one or both engines permanently offline. Standard procedure: glide to lower altitude where the engines could windmill start, or just fly home on one engine. The SR-71 had enough excess performance that losing an engine wasn't mission critical. Try that in a MiG-25. One engine failure at maximum altitude and you're ejecting. The airframe leaked fuel on the ground because the titanium panels only sealed properly when thermally expanded at cruise temperature. Ground crews would tow the Blackbird to the runway, fuel it up, and watch JP-7 drip from panel gaps onto the tarmac. Completely normal. The aircraft would take off, climb to altitude, accelerate to Mach 3+, and the airframe would heat up enough that the panels expanded and sealed. Soviet engineers would have considered this insane. American engineers considered it acceptable engineering compromise. And it worked flawlessly for 3 decades. The Soviets tried to build their own Blackbird. They failed. The MiG-25 Foxbat was Moscow's answer to American high-speed reconnaissance and bomber threats. It looked impressive on paper. Mach 2.83 maximum speed, 67,000-foot ceiling, powerful radar, heavy missile armament. Soviet propaganda promoted it as the most advanced interceptor in the world. Western intelligence agencies initially believed the hype. Then a Soviet pilot defected to Japan in 1976 and brought his MiG-25 with him. Lieutenant Viktor Belenko flew his Foxbat to Hakodate Airport, requested asylum, and handed American intelligence services a complete MiG-25 to examine. What they found was enlightening. The MiG-25 wasn't a technological marvel. It was a brute force design built from steel instead of titanium, because Soviet metallurgy couldn't produce titanium at the required scale. The aircraft was heavy, the avionics were crude, and the engines would literally destroy themselves if pushed past Mach 2.8 for more than a few minutes. The radar was powerful, but used vacuum tubes instead of solid-state electronics. Vacuum tubes in 1976. American engineers were surprised Soviet designers were still using technology from the 1950s. More importantly, the MiG-25 couldn't catch an SR-71 even in theory. The speed gap was too large, the altitude gap was insurmountable, and the MiG-25's combat radius at maximum speed was so limited that intercept opportunities were nearly non-existent. Soviet pilots could scramble, climb to altitude, and maybe, if everything went perfectly, get within visual range of a Blackbird. But visual range isn't weapons range. And weapons range doesn't matter when your missiles can't reach the target's altitude. The Soviets knew this. They continued producing MiG-25s anyway, because they didn't have alternatives. Designing an actual SR-71 equivalent would have required technological capabilities the Soviet aerospace industry didn't possess. Titanium fabrication at scale, sustained Mach 3+ cruise without engine damage, reconnaissance systems that could operate at extreme altitude and speed. The USSR couldn't do any of it. There were attempts. The Sukhoi T-4 was supposed to be a Mach 3 strategic bomber, but the program was canceled after just one prototype. Too expensive, too technically complex. The Soviets couldn't make it work. So they stuck with the MiG-25 and pretended it was competitive. Western analysts eventually figured out the truth. The Foxbat wasn't designed to catch the SR-71. It was designed to intercept subsonic bombers and look intimidating in propaganda photos. The Mach 2.83 top speed was mostly theoretical. Operational performance was significantly lower, and the handful of times MiG-25s actually attempted SR-71 intercepts, they failed completely. I think Soviet aerospace engineers understood the gap. They'd studied Blackbird specifications published in Aviation Week, run the performance calculations, and realized they were decades behind. The SR-71 represented an aerospace achievement the Soviet Union simply couldn't replicate. Not wouldn't, couldn't. This wasn't just about one aircraft. It was about the entire technological and industrial base required to produce something like the Blackbird, the metallurgy, the engine technology, the avionics, the fuel systems, the manufacturing precision. America had all of it. The Soviets didn't. And every time an SR-71 flew over Soviet-monitored airspace, every time Soviet air defenses failed to intercept it, that gap became more obvious. The MiG-25 was a reminder of Soviet limitations dressed up as capability. A steel interceptor pretending to compete with a titanium masterpiece. The Americans retired the SR-71 in 1998. The Soviets never built anything that could touch it. Not before the retirement, not after, not ever. That technological superiority gap? The SR-71 was proof it existed, and the MiG-25 was proof the Soviets couldn't close it. The SR-71 Blackbird flew its last operational mission on October 9, 1999. Not because it was shot down, not because it crashed, not because enemy defenses finally figured out how to kill it. The Air Force retired the aircraft because satellites had become cheaper and congressional budgets made the decision easy. This is the only military aircraft in history retired with a perfect combat record. 0 losses to enemy action across 32 years of operational service. Every mission completed, every sortie successful. 4,000 missiles fired at it, and not one of them connected. The final tally is almost absurd. 3,151 total mission sorties, 11 flight hours at Mach 3+, reconnaissance coverage of denied territory on 4 continents, and absolutely 0 combat losses. Compare that to literally any other Cold War reconnaissance platform. The U-2 lost multiple aircraft to surface-to-air missiles. The A-12, the CIA's predecessor to the SR-71, lost 1 aircraft over North Vietnam in 1968. Soviet reconnaissance platforms had even worse records. But the SR-71, perfect. The retirement decision was purely financial. Operating costs were high. Each flight hour required extensive maintenance, specialized fuel, and highly trained crews. Satellite reconnaissance provided similar intelligence coverage without risking pilots or aircraft. The budget justification became impossible to defend when satellites could do 90% of the mission at a fraction of the cost. But satellites can't do what the Blackbird did. They follow predictable orbits. Adversaries know when they're overhead and can hide equipment or modify operations during coverage windows. The SR-71 could launch on short notice, fly unpredictable routes, and photograph targets whenever intelligence requirements demanded. Satellites can't do that. The Air Force briefly reactivated 3 SR-71s in 1995 for classified reconnaissance missions, then retired them again in 1998. NASA operated 2 Blackbirds for research until 1999, and then that was it. The last SR-71 flight was a ferry mission from Edwards Air Force Base to the Smithsonian National Air and Space Museum. That final flight set a coast-to-coast speed record, Los Angeles to Washington, D.C. in 64 minutes. 64 minutes. The pilot, Lieutenant Colonel Ed Yielding, flew the entire country in barely over an hour, reaching speeds above Mach 3.2. The aircraft arrived at Dulles International Airport, taxied to the museum facility, and shut down its engines for the last time. I think about what Soviet air defense personnel must have felt when they learned the SR-71 was retiring. Relief, probably. Maybe some frustration that the aircraft was leaving on its own terms rather than being shot down. For 3 decades, they'd watched this jet violate airspace, photograph installations, and leave without them being able to do anything about it. And now it was gone, not because they'd finally figured out how to kill it, but because the Americans decided it wasn't cost-effective anymore. That's a humiliation that doesn't end. The SR-71 left service undefeated. Soviet, and later Russian, air defenses never solved the problem. They never even damaged one. The technological gap that the Blackbird represented never closed. 32 Blackbirds were built. 12 were lost to accidents. Engine failures, flight control issues, pilot error. None were lost to enemy fire. That record will never be matched because no reconnaissance aircraft will ever operate that way again. The SR-71 was the last piloted platform designed to penetrate denied airspace through pure performance rather than stealth. And it worked perfectly. The Blackbird sits in museums now. Air and Space Museum in D.C., Museum of Flight in Seattle, Strategic Air Command Museum in Nebraska. You can walk up to them, look at the titanium skin, read the performance specifications on the display plaques. Mach 3.2,